The XV-1 convertiplane introduces a new kind of flight. It rises, hovers, and lands like a helicopter, or flies at the speed of a conventional airplane. The first of its type ever to be built and flown, the XV-1 is part of a joint Army-Air Force development program to investigate the convertiplane principle for application to larger transport-type aircraft. In 1951, following 2 years of basic research, McDonnell Aircraft of St. Louis, in conjunction with the Army and Air Force, began design and development of the XV-1. This design features the unloaded rotor principle and rotor tip pressure jets. The XV-1 has a rotor diameter of 31 feet, a wingspan of 27.5 feet, and is 33.5 feet long. The normal crew of the XV-1 consists of a pilot, with additional space for either an observer, 3 passengers, or cargo. In an alternate version, space provisions are allowed for inclusion of 2 litters. A pusher-type propeller is mounted between the XV-1's twin tail booms, and a Continental R975-19 engine equipped with a cooling fan furnishes the power. The engine drives either the propeller for high-speed forward flight or 2 centrifugal compressors, which provide compressed air to the McDonnell-designed rotor tip jets for vertical and low-speed forward flight. The XV-1 has been flying since July 1954, following an extensive 5-year wind tunnel development, which included full-scale tests at Moffett Field, California. McDonnell test pilot John R. Knoll made the initial helicopter flight on 14 July 1954 at Lambert Field in St. Louis. Typical helicopter controls, cyclic plus collective pitch, and 2 small hydraulically driven tail fans are provided for hovering and low-speed flight. Conventional surface controls consisting of ailerons, rudders, and a floating tab control stabilizer are used for high-speed flight conditions. The pilot turns the fuel switch on and starts the engine. The engine is operated in propeller drive during the initial warm-up. Then, after checking cylinder head and oil temperature gauges, the pilot switches from propeller drive to compressor drive. In helicopter flight, compressed air is ducted to the rotor tip pressure jets and burned with injected fuel. Takeoff is accomplished by hovering with 400 rotor RPM and gradually going into forward flight. After the XV-1 reaches approximately 70 knots, normal rated power is applied and the aircraft enters into a steady climb. Longitudinal control in helicopter flight is maintained through a combination of longitudinal rotor tilt and tail surface deflection. Lateral control combines lateral rotor tilt and aileron deflection. Directional control in hovering and slow forward speeds is obtained from the tail fans. As the speed is increased in helicopter flight, the fixed wing assumes an increasing percentage of lift. The XV-1 flight ranges are divided into 3 basic regimes: helicopter, autogyro, and airplane. takeoff, landing, hovering, and low-speed flight are accomplished as a helicopter with the propeller standing still. Cruise and high-speed flight are accomplished in the airplane regime. Autogyro flight is used during conversion from helicopter flight to airplane flight. At about 80 knots indicated airspeed, the pilot prepares the craft for conversion from helicopter to airplane flight. Pitch is reduced to 6 degrees in preparation for switching power to go into autogyro flight. Engine power is reduced. The pilot switches to propeller drive and increases power. As power is transferred from the compressors to the fixed pitch propeller, the aircraft proceeds into autogyro flight. Airspeed is allowed to build up to 110 knots in autogyro flight. Flight control in autogyro flight is maintained as in helicopter flight by the combined effect of rotor tilt and surface controls. As 110 knots is attained, the pilot shifts the control lever down into airplane flight position, which also reduces collective pitch to 0 degrees. He then allows the airspeed to build up to 120 knots and switches on an automatic governor, which regulates the rotor speed at a fixed value of 190 RPM by regulating to rotor incidence. The XV-1 has now converted from helicopter to airplane flight, the thrust being supplied by the propeller and 85 to 90% of the lift by the wing. The rotor supplies the remaining 10 to 15% of the lift. Airspeed is built up in airplane flight. On April 29, 1955, after a similar conversion from helicopter to airplane flight, pilot John Arnault flew the XV-1 at 158 knots, thereby exceeding by a substantial margin the world's speed record for rotorcraft. In airplane flight, control is maintained by the floating stabilizer, conventional rudders, and ailerons. For conversion back to autogyro flight, the pilot reduces airspeed to 120 knots and then shuts off the automatic rotor speed governor. The airspeed is reduced to 150 knots and held there until the rotor builds up to 260 RPM or higher. At 110 knots, the pilot pulls up on the control shift lever, which increases the pitch to 6 degrees and transfers rotor control back to the cyclic stick. Power is reduced, and at an airspeed of about 80 knots, power is shifted back to the compressors. Following the conversion back to helicopter, the pilot descends and performs a regular helicopter-type landing. Starting on 13 April 1956, the U.S. Air Force Flight Test Center of Edwards Air Force Base conducted a Phase 2 evaluation program at McDonnell. A total of 33 flights were made by Captain Wayne Eggert, Air Force experimental test pilot, in which 5 conversions from helicopter to airplane flight were made. Captain Robert Ferry of the Air Force also checked out in the XV-1 during the program. Excellent maintenance factors streamlined the Phase 2 evaluation program to 3 weeks instead of the 6 weeks anticipated for completion. The XV-1 again bettered all existing speed records for helicopters during the program. Observers also commented upon the excellent handling characteristics of the aircraft, as well as its versatility in the air. While numerous conversions from helicopter flight were made in the NACA full-scale wind tunnel at Moffett Field, the first actual full flight conversion was made in April of 1955. Repeated flight conversions have since been made, proving the practicability and soundness of the unloaded rotor principle. McDonnell has produced 2 models of the XV-1 under contract to the U.S. Army and Air Force. One of the models has recently been equipped with folding wings to enable the company's helicopter engineering division to conduct a thorough study of the craft's hovering characteristics. The XV-1 has completed approximately 40 hours of flight to date. Data, knowledge, and in-flight experience gained by McDonnell, the Army and Air Force in exploration of the unloaded rotor principle in combination with rotor pressure jets will serve in important and necessary functions in the design of future convertiplanes for military transportation, assault, and rescue missions.